Alright, here we have a basic save system that serializes all the actors that are marked as safe via this tag. So these crate actors here are in their class marked as this save tag, and also the first person projectiles are also marked as safe, and it's also going to serialize the player character, although that one shouldn't be marked as safe with the tag. And well, if I start this, you can see if I save while this is in the air, I can reload that, and it's just gonna restore the position and velocity and stuff. The way this works is I just simply delete all of the actors that are marked as safe, and then I reload them from the SaveGame. Also, if I jump and save, you can see that the player's position is restored. Or if I look at the corner and then look away, I can reload that. And yeah, also those things are going to be restored if I reload. And that's all. The way this works is, well, as I mentioned, these have the save tag, which is, other than the player character, all of the actors that are to be saved must be marked as safe with that tag. And yeah, so I have this code here. These functions are implemented in C++, and they do the actual saving. And here, if I currently have for testing these two buttons, F and R. Normally you would probably use something like F5 and F9 or whatever. And here I'll just create an instance of this SaveGame class, which is just derived from uSaveGame. And then I get all the actors with the tag save and pass that along with the player character to the SaveGame function. And then I save this to a slot named default and 0. And when I reload that slot, cast it to that, and pass it to load game, which will then delete all the actors that are marked as safe, and also the player character, and then reload them from the SaveGame. And yeah, other than that, I also have this last shot actor property, which is tagged as SaveGame. Normally this will be hidden, but if you go here, you can see that there's this thing. So that means that the SaveGame thing will automatically serialize this property. And I can show you an example of that. If I select the player character, I can see this last shot actor. If I shoot this guy, it will be marked as crate 2. If I save and reload, there's a bit of an issue with the names because it uses display names. It's now marked as crate 1, but if I shoot this again, it won't change. It's actually a reference to that actor, but this is the display name and not. If I go here and choose ID name, you'll be able to see that these actually do have different names, and this one should be crate 2, but I can't quite show that right now. But it is working. So that serialization works. The way this is set is just in the projectile. I get the player character and set the last shot actor. And another thing that I've tested is in the level blueprint. You can see that I have a reference to crate 2, and if it's invalid, it will say no longer valid, and if it's valid, it will always say still valid after 2 seconds. And if I run this, you will see that it says still valid. If I save and reload, it will keep saying still valid. You can't see it blink because those text prints will last for exactly 2 seconds, and I set this up as 2 seconds. It's another important thing to mention is that delays won't actually be saved properly right now. So if I reload, it won't actually like go back to the tick and start the delay over, or well, actually what it should do is save the current time left and then restore it after, but I haven't done that yet, and I don't know if that's even possible. So delays won't work properly with this SaveGame system as it is. Okay, so here's the source code. I will put that somewhere in the description and you can do whatever you want with it. So here we have our SaveGame archive, which is necessary for the serialization. It derives from f-object and name as string proxy archive, which it takes an f archive, which is used for serialization, and then it treats u objects and f names differently by turning them into strings. The f name will just be converted into a string, and the u object will be converted into its path name. And it also sets AR is SaveGame to true, which means it will ignore all properties that aren't marked as SaveGame. And yeah, so it just takes an f archive and remembers this f archive so that it will later save into that or read from that. And here's some example usage code. Here's for the storing. It will use an f memory writer, which derives from f archive, and point that to this data, which is just a T array of bytes. So in C++ that would be called U and 8. And then the SaveGame archive will point to that memory writer, which will then write into that data. So here we have a serialize call on an actor, and because this is a memory writer and not a reader, it will take data from the actor and put it into the archive. And here's the opposite, which uses just a memory writer, a memory reader, and it will read from this data and put it into this actor. So it both calls serialize, but this method will, depending on if it's reading or writing, it will either put that data into the actor or take it out of the actor. And that's how that works. So this call will just read all the properties that are marked as SaveGame, and this one will write all the properties that are marked as SaveGame, because this archive is saying that it's the SaveGame. And yeah. So for each actor, we're creating one of these things. It's an f actor record, which is just a ustruct, and Unreal Engine knows how to serialize these. So they will be put into the U SaveGame later and will be automatically serialized. This here is just, I'll get to that later, it's not actually part of the SaveGame data. And here we have the things we actually need to save. This is the class, so that when we respawn the actor, it will know what class to spawn. And the name is also important, because for the references to be restored, it needs to have the same name afterwards. And the data is for the serialization of those properties that are marked as SaveGame. Then we have for each component, that is, right now the system does not properly save dynamically added components. It only restores the ones that were already in the class when it's normally spawned. So that those are put into a different record, which we'll get to later. Yeah, and then we have the transform, which is just the transform, which will be restored after spawning. And the lifespan is just, well, each actor has a lifespan that after a certain number of seconds it will automatically destroy. For example, the projectile has a lifespan somewhere, initial lifespan of 3 seconds. So this needs to also be saved. And this is actually a problem with the system, because when you make your game, you will keep running into more data that you need to store. And for example, here I had an AI destination, which I haven't quite done yet, because it's actually more complicated to properly restore the movement of an AI character, because they have things like acceptance radius and movement can be paused and all that. I haven't quite figured that out. Only I actually start a whole new path after loading, which I commented out for now. And yeah, so let's get to the actor record, component record. It also has a class, a name, and a transform, which is only for using components, which have a transform relative to their parent. And it also has data because components also have properties, and they can also be marked as SaveGame. And that's all that goes into this data. And also for primitive and movement components, it has a velocity, and only for primitive components I use an angular velocity. So these are a little bit ugly because not every component has them, but that's just how I did it for now. Here we have the actual SaveGame. It has the player controller rotator because I'm not serializing the player controller. I'm just serializing or storing the player controller rotator because the player is using the control rotation. So we need to get that back so that the player will look in the same direction after loading. Then the player actor record is outside of the other actors because it needs some special handling, for example restoring the control rotation after loading. So I've decided to put that outside that array. And this is the array of all the actors that are marked as safe with that tag. And yeah, these are the two methods. This one saves the game, it takes the player actor and an array of all the other actors that are marked as safe. And the load game is, well, it takes a world context object, which is a special thing which takes an object that knows the world. So as you can see here, I'm not actually passing that object in. It's automatically passed in because of this. And yeah, the load game function needs the world because it needs that to spawn stuff and get the player and all that. Yeah, so here's all of the code that actually does stuff. I'm going to start with SaveGame. Yeah, it takes the player and all that, checks if it's null, and it empties the actor array. Normally this would probably be empty because you probably make a new SaveGame to store the game in, but if you reuse one, then it empties those. Then it uses the function createActorRecord to take the data from this actor and put it in this actor record. Yeah, here it stores the rotation of the player controller, and then it goes through all of the other actors and makes a new actor record for them and creates, well, it stores the data of the actor inside that record. So let's look at createActorRecord. Here, as I've shown you before, it uses a memory writer and writes into the data of the record. The serialize is down here, and then it stores all these other properties: the class, the name, transform, and lifespan. And then it goes through all of the components. It makes a component record, stores the class and name, and then here's the ugly part where it has special handling for different types of component. If it's a scene component, it stores the transform, and if it's a primitive component, it stores the velocity and angular velocity, and if it's a movement component, it also stores the velocity. So this field here is used for two different types of velocity. But of course, no component is at the same time a movement component and a primitive component, so that doesn't matter. Yeah, here it just serializes the properties of the component. Now let's get to load game. So load game is all the actors are loaded in two passes. So first I have a function called load actor, which spawns all of the actors, and then there's another one called finish load actor, which finishes the spawning of the actors. Which this is necessary because if we want to restore all the references between actors, all of them have to exist before the spawning is finished. So that's why we have to go through all of them twice. So here we first get the world, then we destroy the player. If in a real game you would probably want to check if the player is null in case you want to reload after the player died or something like that, but here I'm not doing that. Yeah, so it gets all the actors that are marked as safe and destroys all of them. Then it loads the player and loads all the other actors. Then it finishes loading the player. I'll show you this function later and this one too. And here I get the player controller, possess the player actor, which I've mentioned this field earlier. It's not, where is it? Here. It's not really part of the SaveGame data. It's just so that we can pass a pointer to the actor from the load function to the finish load function, so that we still know the actor, and here I'm also using that to get the player respawned, to possess it by the controller. Then I reset the control rotation to what we have in the save game, and then I also call update rotation. This here is like a delta time value, which doesn't seem to do anything, but I'm just passing this nonsense in there because you have to. Maybe I should figure out exactly what that does, but it seems to work. And then I just finish all the other actors. And let's get to load actor. Here we have spawn params, which are passed later to the spawn actor function on the world. And it gets the name, which is of course important so that we can restore the references. Defer construction is also important because otherwise the spawn actor function would automatically finish the spawning of the actor, which is not what we want. We want to do that later in finish load actor. And this is just, I tell it to always spawn, but it probably doesn't matter because the actor shouldn't be colliding with anything when it's loaded because it probably wasn't when it was saved. Whatever. And yeah, it takes the class, so it knows which class of actor to spawn, and the transform, so it knows where to spawn it. And I also set the lifespan, and here I restore all the data from the properties marked as SaveGame. Yeah, and then I also set this pointer so that we know it again later. And then we call finish load actor on that. Yeah, the A will then be pointing to the spawned actor, and then we go through all of the components again. This only goes through components that were already in the class when it's being spawned. As I mentioned, the system currently doesn't handle dynamically spawned components. And yeah, it goes through all of the ones in the record, and then all of the ones inside the actor, and compares them to see if it's the same one. And yeah, then it deserializes all of the component data, all the properties. And here we have basically the same as we had in the save function, except doing the opposite. So we check if it's a scene component. If it is, we set the transform with this stuff here, which, well, teleport is probably important because teleportation basically means it's not considered a movement. So if you have any kind of cloth or whatever on your actor, it won't react to that movement. And here we have the primitive component. If it is one, we restore the velocity and angular velocity. And we also, because if you have this one, for example, it's smaller than the actual class, than it is inside the class. So I changed the scale on that one. And that means that when you change the scale, it will dynamically adapt the mass of the object. But if you restore it from the save game, it normally wouldn't do that unless you call update mass properties. So otherwise it would get heavier after the loading, and then you might not be able to move it anymore. So of course we want the mass to stay the same before and after loading. And here I just restore the velocity. This one I think you're supposed to call that, but it didn't seem to make a difference. I didn't need that, but I don't know. You can leave that out if you want. And then of course I'm calling finish spawning, which will call begin play and such. So if you're using references to other actors inside begin play, then these will already be restored at this point. And it also takes the transform, which is a little weird because the spawn actor already took the transform. I don't know why it wants that twice, but it does. And that's it. If you've noticed any problems with it or you have any feedback for me, please let me know in the comments, and thanks for watching.